My name is Engineer Mark Anthony. I am a professional civil engineer in the Philippines, and then at the same time, I am a registered civil engineer in Doha State of Qatar. Uh, I just want to discuss with respect to some of the questions and inquiries of the some of the civil engineering students, which I'm always found on Facebook. So that actually, when I was in college, I'm always very much interested when it comes to fluid mechanics, hydraulics, and hydrology. Those are some of the subjects which I am very much interested. So, uh, first thing first, actually, some of the students are very much well capable when it comes to the theoretical aspect of these subjects, specifically on the fluid mechanics and hydraulics. And but work-wise, when you are going to apply it based on the actual applications, when you are now in the field, it is very much better that you are aware with respect to the theory, and then at the same time you are very much aware with respect to the application. So first, we have to discuss you, as being a student first, you should have to be aware what are the types of materials that are going to be used, the area of application, which is much more very important, and then at the same time, what are the process of testings and the methods, procedures, and applications in order to utilize those materials, and also scope wise also. Now we have to discuss first with respect to the materials, we have to discuss the types of pipes. Let's say for example, uh, there are pipes which is known as the MUPVC, or known as the modified unplasticized uh, polyvinyl chloride. And at the same time, we have also the PVC, UPVC, and then at the same time, we have the PPR, or the polypropylene random, and then we have also the HDPE, which is the high density polyethylene. There were also MDPE, which is known as the medium density polyethylene. And then at the same time, we have the carbon steel, we have the black iron, we have also the MS, or known as the mild steel, and then we have, let's say, ESBC, or known as the extra strength vitrified clay pipe. Those particular pipes have its own area of applications and usage. Let's say, for example, we have the MUPVC, and then at the same time we have the PVC. And then at the same time, let's say for example, the UPVC, there are two types of category. We have the below ground, and then at the same time the area of application, which is above ground. So normally when I was working in buildings, we are using the BS4514 when we are going to install the riser main of the plumbing works on the building, because that is above ground. And when it comes to the drainage system, which is buried underground, so we are going to use the BS4660. So, and at the same time, there were two types of pipes also based on categories. So we have the rigid, and then at the same time we have the um, flexible pipes. Let's say, for example, those flexible pipes are, let's say, for example, we have the PPR, and then at the same time we have the HDPE also. Now, let's say HDPE, when we talk about HDPE, normally these are being used in irrigation systems, in TSE here in Qatar, and some other countries also in the world. TSE, or known as the treated sewage effluent. What is a TSE actually? TSE came from the sewer. TSE came from the sewer microtunneling, and then at the same time foul sewer system, which is came from the households, and then at the same time this will go to the pump stations, and then at the same time pump stations will process this and pump this system going to the treatment plant, and then at the same time treatment plant, we are going to remove the unsuitable materials from the water and treat it properly, and it will be recycled, and at the same time it will return back to the community by means of industrial use, or let's say for example by means of irrigation system. So instead that they are going to process the what you call electrolysis and other distillation process, these are one of the methods in order to utilize, in order to also to enhance the recycling process of water. This is called as the what you call sustainable development of a country. Now, HDPE, normally HDPE are being used in TSE. Now, what is the category and what is the technical, what is the technical applications of TSE? TSE properties actually, I'm sorry, HDPE, I'm talking about HDPE. The HDPE, the technical categories of HDPE, it is considered as a flexible, and then at the same time it is always being used as a pressurized pipes, and it can be used also for treated sewage effluent, it can be used also for surface water, it can be used also for foul sewer. It has so vast applications, and then at the same time it can be used for a method known as the HDD, or known as the horizontal direct drilling. So when it comes to the process of identifying the properties of HDPE, which is known as high density polyethylene, so there are categories. You can identify the properties of HDPE when it comes to the pressure ratings, and at the same time when it comes to SDR value. Okay, what is the pressure rating? Actually, that is the resistance of the pipe when it comes to when it will be pressurized. Actually, let's say for example we are using mostly PN16, or nominal pressure of 16 bar, let's say for example, that is the concept. And at the same time it has an SDR value of SDR11. So when you say SDR value, that is the standard dimension ratio. So meaning to say, whatever the diameter of the pipe, you can get the thickness of the HDPE pipe when you are going to divide it by its SDR value. Let's say for example, I have the 250 mm diameter pipe. I have to divide that by 11. So meaning that is now the thickness of that is now the wall thickness of the HDPE. There are also concepts which being used, they are using SDR11, I'm sorry. So sometimes they are going to use that in the crossing ducts and electrical crossing ducts. And the SDR11, they are using that for pressurized pipelines, especially on TSE also, and irrigation system. And at the same time, there is another one also, or known as the clay pipe, ESBC. Normally that is came from, that is being used from the old concept of drainage system. Actually, those clay pipes are now already obsolete, and they are being replaced by GRP, and at the same time by HDPE. And due to the hard difficulties in production also, and it is very labor intensive when it comes to pipe layings and handling also. And now there are two types of clay pipe, actually, known as the extra strength vitrified clay pipe, and then at the same time we have the standard strength vitrified clay pipe. And actually they are being used in the surface water and also for the foul sewer. Now, in surface water, there are two types of applications. We have the solid pipes, and then at the same time, we have also the semi-perforated or three-port perforated pipes for the vitrified clay pipe. But in foul sewer, since it is a waste product, it is all solid actually. And now, we will talk about the GRP. Now, what is the technical properties of GRP? Actually, GRP, it can be actually identified when it comes to the technical. It can be evaluated. What I mean, when it comes to the technical aspect of GRP, you can evaluate that based on pressure ratings, and then at the same time its resin value, and then at the same time its stiffness value. So when it comes to the GRP, you should have to always identify what is the pressure rating. Let's say for example PN16. So the nominal pressure, it depends on, first you have to identify what is the area of application, and then at the same time you have to identify based on specification what is the required pressure rating. So let's say I'm going to use PN16. Okay, you can identify based on pressure resistance, you are now safe. But when it comes to the pressure surrounding the pipe, when it comes to GRP, you should always have to consider the stiffness value of GRP. So normally there are different stiffness value based on area of application. Let's say, for example, PN10 or nominal pressure of 10 bar. So it has only a stiffness value of 5,000 Pascal. So if we have the PN16 or 16 bar pressure ratings, you should have to identify also what is the stiffness value for this before we're going to install on site, because the backfill resistance, when you're going to backfill this pipe, it has a resistance to backfill of 10,000 Pascal or Newton per meter squared. So meaning you have the resistance to the pressure that will act at the internal diameter of the pipe, and then at the same time you have the resistance to the pressure acting outside the diameter of the pipe. So when you are going to identify GRP technical properties, you can have the stiffness value, which could resist the pressure outside the pipe, and then at the same time the internal pressure acting on the pipe, pressure rating, and then also the pressure acting outside the pipe, which is known as the stiffness value of the GRP. And then at the same time, we are going to discuss also with regards to the other process, the mild steel, and then at the same time we have the GI, galvanized iron, and then at the same time black iron, the area of application. Sometimes black iron are being used on the industrial sewer system. Mild steel are being used in the chilled water system, and also water supply. And then at the same time we have also the copper pipes, which are being used in buildings. So copper pipes also are being used in hot and cold water supply, but the area of connections, there are only two categories of how you are going to join, to weld. I'm talking about to weld the copper pipes. Actually, the two applications, this is called as soldering and only bracing. Bracing, you cannot brace any other metal except for copper. So that's the case, that's the concept. Sometimes there is what we call also threading, soldering, threading. So I'm talking about three methods. We have the soldering, we have the threading, and then at the same time we have the bracing. So what is the difference between soldering of copper pipe and bracing of copper pipes? So when the pipes, the area of applications of copper pipes, when it will be used for a higher pressure environment or area of application, let's say for example refrigerant piping system, so it will be subjected for a high level of pressure. So the method that you are going to use in order to weld the joints of the copper, you have to introduce a bracing method. When you are going to use a high level of temperature, let's say for example from 460 degrees centigrade, you have to use bracing method. When you are using a bracing rod actually. So the temperature when you are going to join between two copper pipes, it must be with a minimum of 460 degrees centigrade. Okay, when you're using only for some common applications, let's say for example in water supply, hot and cold water supply, you can use the normal soldering process. So you can weld that by lead in some other jointing elements when the temperatures can be used more than 460 degrees Fahrenheit. So the rest, that is for now. So if there were some questions and answer, we can give you later on directly. So thank you very much for having me today. So once again, have a nice day and good morning.